Here we go. More chemical reactions potentially from the AB Chem exam. Question number 4. A solution of hydrogen peroxide is catalytically decomposed. Key word here is decomposed. Why is my pen not working? Decomposed. Okay, catalytic just means what? Speeds it up. Hydrogen peroxide, H2O2, decomposes into H2O plus O2. It's a reaction your chemistry teachers probably talked about. Water is more stable than hydrogen peroxide. This reaction happens. In order to balance it, put a 2 there and a 2 there. The reaction is balanced. So this is a decomposition reaction. It's also a redox reaction. How can we tell? Well, over here they're asking what's being oxidized and what's being reduced. So good strategy there. Look for oxidation numbers. Oxidation number of hydrogen, +1. Oxidation of oxygen or peroxide is -1. Hydrogen is +1, so nothing is happening to the hydrogen. The hydrogen is neither being oxidized or reduced. What is happening is the oxygen is being both oxidized and reduced. Oxygen goes from -1 to -2, so that is gaining in oxidation number. That means it's being reduced. It's gaining electrons. On the other hand, the oxygen is also being what? It's going from -1 to 0. It's being oxidized. It's losing electrons to oxygen. So this is an example of a reaction where the same reactant is acting as both the oxidizing agent and reducing agent. This is called disproportionation. One substance acts as both the oxidizing and reducing agent. Name the element being reduced and the element being oxidized. It's oxygen. All right, interesting reaction. So decomposition, this is also redox. Time to change color. Let's spice it up a little bit. Let's go to green. A solution of potassium iodide is electrolyzed. Potassium, almost always spectator. Throw it out. So really we've got iodide. Got to have something else in here, so we've got water. We're passing electricity through the system. Okay? Electricity is going to cause things to break down. So electricity is going to stimulate some kind of a decomposition or rearrangement. The rearrangement that happens here is the iodine gets oxidized to iodine. The iodide ion goes to iodine. The other product of the reaction is that we produce hydrogen gas and some subsequent hydroxide. Okay. Now, in order to balance that reaction, I'm going to need to put a 2 here. That balances the iodides. I'm going to need to put a 2 here and a 2 here, and I think that balances it. Remember, in a redox reaction, in any reaction, the charge has to balance. There we are. The iodide, time to change color, purple. Iodide is going from -1 to 0. It's being oxidized. It's losing electrons. The hydrogen is going from +1 to 0. It's being reduced. It's gaining electrons. There's our redox reaction, okay? At what electrode would the gas be released, okay? Gas is being formed by the reduction, therefore that would happen at the cathode. The cathode is where reduction occurs, okay? The cathode is negatively charged. It's the source of electrons. Again, in order for the reduction to occur, we need a source of electrons. Reduction is gaining electrons. All right. A solution of copper 2 sulfate is electrolyzed using inert electrodes. Okay, so again, this is redox. Similar reaction. Copper 2 sulfate, CuSO4. The 2 refers to the charge in the copper. Okay. We've also got some water present. Sulfate ion is a pretty stable thing, so it's not going to change. Sulfate is actually going to be a spectator. So we're just going to write that as copper +2. Pretty easy. Copper +2 is going to be reduced. The copper, if something is being reduced, something has to be oxidized. Okay? What's going to be oxidized is oxygen. The water, oxygen and water gets oxidized to O2, and we've got a couple of hydrogen ions left over, and that should balance the reaction if I put a, what? If I put a 2 here and a 4 here. Make sure you've got a pencil with a good eraser. There's our reaction. The copper is being reduced. The water is being oxidized. Oxygen is going from -2 to 0. It's losing electrons. It's the oxidation. All right. Is the final solution acidic, basic, or neutral? Since the solution produces hydrogen ion altogether, it is acidic. It produces H+. pH is less than 7. All right, good. So a little bit of electrochemistry here. Electrochemistry is forced redox. Excuse me, electrolysis is forced redox. We have to add electricity when a reaction goes in the non-spontaneous direction. Okay? Everybody good? Super. All right. Finally, one more reaction here. A solution of ammonium sulfate. So I can write that. Ammonium sulfate plus barium hydroxide. BaOH2. All right. 2 solutions of ionic compounds. Not surprised? Compounds containing ammonium ion are always soluble, so ammonium sulfate, soluble. Barium hydroxide, okay, a saturated solution of barium hydroxide. Barium hydroxide, not real soluble, but soluble enough. Okay, they mix together. Your prediction here is going to be an ionic switch reaction, a double displacement reaction. The ammonium is going to get together with the hydroxide. The barium is going to get together with sulfate. So we're going to end up with barium sulfate for sure. And we're going to end up with a combination of ammonium ion and hydroxide ion. Okay? Ammonium ion and hydroxide ion. We can write that. That would probably be acceptable if we're going to balance it. We put a 2 there. Ammonium ion is going to be a spectator ion. So a better reaction might be, say, let's just get rid of the ammonium ion. Come back. Sulfate reacts with barium hydroxide to form barium sulfate and 2 hydroxide ions. Okay? This is a precipitation reaction. Identifying a precipitate form, the barium sulfate would be the precipitate. Okay. All right, 4 more.